Hi, I'm Mikey Sklar of Holy Scrap Hot Springs, and today I want to show you how I repair sealed lead acid batteries. So here's a old sealed lead acid battery. It's pretty rough. It's been sitting in my yard for about 4 years uncharged. I really haven't looked into it at all, but I can tell you before I even start working with this battery, it's dry. It needs water. So let me go through the process of how I recover sealed lead acid batteries. So the first step in recovering any battery is just to clean it up a little so you don't make more of a mess. This is some biodiesel, but any type of olive oil or kerosene would also work for just really cleaning up the outer casing. You can see it looks a heck of a lot better already, minus all the crap that's on there. But we just want to keep the battery really clean when we open it up so we don't spill more dirt in. The next step with recovering a SLA battery is we're going to have to cut this thing open. So I have this kind of razor that I'm just going to go around the edge and really try to get in to this edge to the point where I can pry this top off. And what I find if I do about 3 passes with the razor, it's enough that I can start sliding the razor under. So I went ahead and just placed the razor right in here, straight up and down, and just started to pry it right up. See how I just do that tilt, and you can see it starts to lift. We're really starting to see some lift here. Then I go around and just keep doing that. And once I feel like I got a side pretty well up, we can switch over to a screwdriver. Kind of use that combination now to really lift it up. We want to be gentle. We don't want to crack the top. So just gently work the screwdriver in under the case. Real slow. Take your time. I have cracked these before. It's embarrassing. Yeah, great. So got a little dirt. Go ahead and clean that up. Now, I have not tried to charge this battery in the last 5 years, so it's okay for me to open these caps. But if I had been messing with this battery and trying to charge it before I refilled it, these caps would be very dangerous. They could actually spit out any liquid that was in there when it's being opened. There'd be a lot of pressure, potentially, if this had just been charging. So these caps come right off. You can wear gloves if you want. I find they're really difficult to manage with gloves on. And you go ahead and just pull these caps right off with your fingers or with the screwdriver. You're going to want to save them. Okay, you can see we got all the caps off, and it's time to start refilling these cells with water. I have a little cup of rainwater here, and I like this meat syringe. You can buy these at, I don't know, Walmart and big box stores and such, but this meat syringe is really ideal. I took off the metal syringe tip and just have its own little screw-on thing, but check this out. I just stick it in the cup, fill the syringe, and just put it right over each cell, and you can fill fast. And this battery is so dry, it's going to take between 20 and 30 milliliters per cell, so it just took an entire syringe on that first cell. Just keep filling, and do this for every cell. Just fill them up with water. I find a dry battery can take just about 1 full syringe, which according to this is 30 milliliters. So I just went ahead and filled this battery. I did all 6 cells. It took about a third of a pint of this mason jar here of rainwater to do that, and now it's time to charge it up. So I'm going to go ahead and use the pimp charger, and there's 2 leads for the DC side, a positive and a negative, so those need to be placed correctly orientation wise. So black to black, red to red, and there's a little AC plug. In my case, in the US, it's a 110 volt, but international 220 is fine. You just need the prong adapters for your plug shape. And I'm going to go ahead and start charging this. So you can see you're going to go ahead and plug in the AC side, And let's take a look at what the voltage reading we're seeing on the PIMP right now is. So before charging, I'm seeing about 0.6 volts. It's a little bright out. Yeah, 0.6 volts. So that's really bad for a 12-volt battery. So you know what? Because I know this battery is going to have a ton of resistance, I'm going to turn the display off before I start really charging and hitting the black switch. So here we go, turning on the PIMP. So I've been letting the PIMP battery charger work on this battery for about 1 minute, and the whole time I left the voltage display on, but I'm going to go ahead and turn it on now, and I'm sorry, I had it off the whole time, and we're just going to see what the voltage is reading. So it's up in the 55, I would say 45 to 60 range. It's jumping all over the place as it's pulsing and recovering here. So what I'm going to do is let it run for about 10-15 more minutes and see where we start to stabilize at. And I'm going to do a quick check of each cell at that point, because what I'm really curious about is this battery going to be able to recover? And we can find out very quickly if it's going to have a full recovery. So I'm going to go ahead and turn off the display, let it keep charging 10-15 minutes, and I'll come back. So you can see we're down into the 20 to 30 volt right now range for this battery recovery, which is pretty good. The resistance is still very high after even 15 minutes of letting it sit, so I'm going to have to let it keep charging. But what we can do is we can turn off the charger, see what it drops to. It's sitting at about 11.8 volt right now, 11.7. It'll keep dropping a little bit. And we can check each cell, and we can check and see which of these cells might be dead or weaker than others, and get an idea of how the battery is doing out of its 6 different components. So one of my favorite tricks is to use a multimeter, set it to voltage DC, and take its 2 probes, positive, negative. I leave the positive right on the positive terminal of the battery and dip the negative into this acid for each cell. First cell, we're reading 1.2 volts. That's great, because if it were fully charged, we'd be seeing somewhere between 2 and 2.5 volts. Second cell, seeing about 3 volts. Great. Third cell, 5 volts. Fourth cell, 7 volts. Fifth cell, get a little more in there, 9 volts. Sixth cell, 10 volts. And then finally at the final terminal, 11.3 for what the battery's holding on its own right now. And it's going to still drop a little bit real slow because we were just charging it. But you know what? This is the battery that's going to recover. This is a battery that we can get quite a bit of capacity out of still. Every cell is good. Now, if I had been trying to charge this battery without... if I had been trying to charge this battery and hadn't added water, I would have blown a connection to one of the cells, and we would not have 6 working cells as we do here. We would only have like 5 working cells, and that's why adding water is just one reason it's so critical to add water, so you don't blow out the cells. So this is a great battery. We just need to keep charging it. It's going to come back and have a long life.